Assalamualaikum warahmatullahi wabarakatuh. So, today I will do a review for chemistry. Uh, was by me, Faizan Raqila F from 10E. First of all, I want to honor our teacher, Ustazah Helena Rohilahi SPDGR. And then let's just start the chemistry review. We start by the paper 1 at the question number 3. A radioactive isotope of thallium is used to assess damage in heart muscles after a heart attack. Which statement about thallium is correct? Well, thallium has a atomic number of 81, meaning it has 81 protons in a neutral atom. The number of electrons equals to the number of protons, so it also has 81 electrons. So the correct answer is B. We move to the question number 5. Which molecule has an equal number of bonding electrons and lone pair electrons? As we know, in carbon dioxide, the carbon atoms forms two double bonds with two oxygen atoms, giving 8 bonding electrons, and carbon has no lone pairs, while each oxygen atom has 2 lone pairs, making 8 lone pairs electrons in total. So the carbon dioxide is the correct answer, B. We move to the question number 6. Methane and steam react to produce hydrogen. 0.80 grams of methane and 1.35 grams of steam react, one of the reactants is used up. Which volume of hydrogen measured at room conditions will be produced? First of all, we calculate the number of moles from each molecule, and then by the equation, the mole of CH4 we times with 2, then only 0.075 mole is available, so H2O is the limiting region, and then we use the ratio 2 mole of hydrogen dioxide produce 4 mole H2 and 0.075 mole hydrogen dioxide produce 0.15 mole hydrogen. So at room conditions, 1 mole of gas occupies 24 dm to the power of 3, and then we times with the mole of hydrogen, and then we got the correct answer, that is 3.60 dm. So the correct answer is B. Next, we move to the question number 7. We're gonna use an ideal gas equation with the P is we convert from 103 kilo pressure to the 103,000 pressure, and then the volume, the temperature, and the R. First we calculate the number of moles by using the formula, and we got 0.20 mole, and then we molar mass of methane, we must calculate it, and we got 60 gram divided by mole. Calculate the mass, and 0.20 mole times with 16 gram per mole, then we got 3.2 grams. So the answer is D. And then for the question number 8, sodium azide is an explosive used to inflate airbags in cars when they crash. It consists of positive sodium ions and negative azide ions. What are the numbers of electrons in the sodium ion and the azide ion? Well, sodium has an atomic number of 11, so a neutral sodium atom has 11 electrons. The natrium ion has lost one electron, so it has 11 minus 1 goes to the 10 electrons, and each nitrogen atom has 7 electrons, so 3 nitrogen atoms, 3 times with 7 equals to 21 electrons. The acid ion has gained 1 extra electron because of the minus 1 charge, so 21 plus 1 is equal to 22 electrons, so the correct answer is B for the sodium ion 10 and acid ion 22. Then we move to the question number 10. Mm, P, Q, and R represent 3 different structures of element. Which structures are giant molecular? P is graphite, which has a giant covalent giant molecular structure. Q is diamond, which has also a giant covalent structure. R is Buckminster Fullerene, which acts as a simple molecular substance made of individual molecules, not a giant network. So the answer is only P and Q are giant molecular structures, or B. And the next one is question 11. What is the shape of the sulfur dioxide molecule? Well, sulfur dioxide has 3 regions of electron density around the sulfur atom, 2 bonding pairs and 1 lone pair. According to VSEPR theory, the lone pair repels the bonding pairs, causing the molecules to have a band nonlinear shape. So the correct answer is B, nonlinear. Question number 12. In which pair do the molecules have the same shape as each other? The correct answer is B, hydrogen dioxide and HCl2, sodium chloride. Both molecules have a band shape because their central atoms, oxygen and sulfur, both have 2 bonding pairs and 2 lone pairs of electrons. Question number 14. Ammonia reacts with acids to form the ammonium ion. As you can see the chemical equation. Which row is correct? Well, when ammonia gains a hydrogen ion, its single lone pair becomes a 4th bonding pair with 4 identical bonding pairs and no lone pairs around the central nitrogen atom. The molecule adopts a perfect tetrahedral shape with a standard bond angle of 109.5. So the correct answer is D with the shape tetrahedral, and the angle is 109.5. Question number 15. P bond is formed by the sideways lateral overlap of 2 parallel p orbitals. Well, the order's incorrect. Like diagrams A, C, and D all show head-on axial overlap along the internuclear axis, which form a sigma bond instead. So the correct answer is B. Next to the question number 16. First, we calculate the heat release by using the M times C times delta temperature, which equals to 50 grams times with 4.18 times with 15 equals to 3.135 joule. And then we calculate the moles of acid, N equals to volume times with concentration, 0.0250 times with 4 equals to 1.100 mole. And then finally we calculate the enthalpy change by minus Q per divided by N by mole equals to a minus 31.35 kilojoule per mole. So the correct answer is B. Yes, the B. If we make the number rounds to minus 31.4. Question number 17. A student performed an experiment to measure the enthalpy change of combustion of ethane. He used the following values for the standard enthalpy change of combustion of carbon and hydrogen. As you can see, the enthalpy change of carbon and enthalpy change of hydrogen minus 394 and minus 286. He calculated the enthalpy change of formation of ethane to be minus 140. What was his experimental value for the standard enthalpy change of combustion ethane? So, as you can see, the formation reaction for ethane is 2C plus 3 hydrogen uh, was carbon was C2H6. Then we use the Hess law, that is the delta enthalpy final equals to enthalpy change of reactants and enthalpy change of products. So we get a minus 140 equals to 2 times with minus 394 plus 3 times with minus 286 minus with the enthalpy change of ethane. And then finally we get the and then using the algebra we get the enthalpy change uh, was minus 1506 kilojoule per mole. The answer is B. Then we go to question number 18. Carbon monoxide and methanol can react together to form ethanoic acids. Standard enthalpy change of combustion are given in the table. As you can see, what is the value for enthalpy change for the reaction between carbon monoxide and methanol? We use the Hess law again. Minus 283 plus minus 726, then plus 874.1, which we got 100 minus 134.9. The answer is B. Question 20. A student calculated the standard enthalpy change of formation of ethane using a method based on standard enthalpy change of combustion. He used correct values for the standard enthalpy change of combustion of ethane and hydrogen, but he used an incorrect value for the standard enthalpy change of combustion of carbon. He then performed his calculation correctly. His final answer was minus 158 kilojoule per mole. What did he use for the standard enthalpy change for combustion of carbon? Using Hess law again, we input the number in there. Oh, wait. Is there a problem? Wait. Okay. Sorry, there's a little problem. Okay, using the Hess law again, we use the Hess law again, and then we input the number uh, for the enthalpy change. At the final result, we got that X is equal minus 430 kilojoule per mole. It was C. Question number 22. In the conversion of compound X into compound Z, it was found that the reaction proceeded by way of compound Y, which could be isolated. The following steps were involved. X to Y, the enthalpy change is positive, but Y to Z has a negative enthalpy change. Which reaction profile fits this data? Isolation of Y, because compound Y can be isolated, it is reaction intermediate. Intermediates must sit in an energy valley between two activation peaks. Immediately narrows the option down to profile A and D. Energy level. Enthalpy change X to Y is endothermic because it was a positive enthalpy change, so Y must be higher than X. Y to Z is exothermic negative, so Z must be lower than Y. So A is the perfectly match to this criteria. Next to the number 23. Carbon monoxide and metal can react together to form ethanoic acids. Standard enthalpy change of combustion are given in the table. As you can see, this table, what is the value of for enthalpy change for the reaction between carbon monoxide and methanol? Well, this is a same question like number 18. So maybe you can hear the explanation in number 18 again. Wait. Yes, it's totally same. Yeah. So you can hear my explanation. Listen to my explanation at number 18. Question number 24. What is the definition of standard enthalpy of neutralization? Uh, it was D when an aqueous acid and an aqueous alkali react together to produce 1 mole of water. By strict chemical definition, the standard enthalpy change of neutralization is the enthalpy change when an acid and alkali react together under standard conditions to produce exactly 1 mole of water. Okay, move to the number 25. The enthalpy change of neutralization given below is minus 114 kilojoule per mole. As you can see the equation at here. By using this information, what is the most likely value for the enthalpy change of the following neutralization? The standard enthalpy of neutralization is the energy released per 1 mole of water formed for any strong acid reacting with a strong base. So the neutral enthalpy changes was minus 57 because it was divided by 2, and then to find the total of enthalpy change, we're gonna times the formula with we're gonna times moles with the enthalpy change neutralization. Uh, by this fraction, we input the number that is 2 moles and minus 57 kilojoule per mole. It was equals to minus 114 kilojoule per mole. That is C. A student makes 25 centimeters cube of 0.100 mole dm minus 3 to the power of minus 3 sodium hydroxide solution with 25 cm cubics of 0.100 mole dm minus cubic hydrochloric acid, and the student records a temperature rise 2.50 Celsius. What's the enthalpy change of the reaction per mole of natrium hydroxide? Using the formula, first we calculate the mass. By 25 plus 25 was equals to 50 grams, and then heat mass times with the C times with the delta temperature, then we got 522.5 joule, and then moles. 0.100 mole dm minus cubic and 0.025 dm cubic equals to 0.0025 mole. And then using the enthalpy change formula, that was minus Q divided by moles. We got the final answer is minus 209 kilojoule per mole because it was converted to a kilojoule from joule. The standard enthalpy change of combustion of glucose and ethanol are given as minus 2820 and minus 368 kilojoule per mole respectively. Glucose can be converted into ethanol. What is the standard enthalpy change for this reaction? As we know, we use the Hess law again. Reactants minus products. Then with the quick calculation, minus 2820 plus 2736, then we got minus 84 kilojoule per mole. The answer is B. In which reaction is the underlying substance acting as a base? Of course, it was C. At C, HCO3 with the charge min acts as a base because it accepts a proton from HNO2 to form H2CO3, which subsequently decomposes into carbon dioxide, water plus carbon dioxide. Yes, and the next one is 32. Uh, Four mixtures are added to four separate 50 centimeter cubic samples of water and stirred, which mixture result in a solution with the highest pH. Highest pH means the most alkaline solution. Magnesium oxide is a strongly basic metal oxide that reacts with water to form alkaline the magnesium hydroxide, producing a pH around 9 till 10. The other option contains oxides or chlorates of aluminum, silicon, and phosphorus, which form either completely insoluble neutral structures or highly acidic solutions, resulting. So the correct answer is B. Next, number 34. Uh, the curve shape is the titration curve starts below pH 1, strong acids, and ends near pH 14, very strong alkali. This rules out B weak alkali and D weak acids. Mole ratio starting volume of acid P equals to 20 centimeter cubics, equivalence volume of alkali Q equals to 10 cm cubics from the graph. Since both have the same concentration, it takes half the volume of alkali to neutralize the acids. The alkali must neutralize twice as much acid per mole. So the correct answer is C. Question 35. In which reaction is water behaving as a Bronsted-Lowry base? According to the Bronsted-Lowry theory, a base is a proton acceptor. Therefore, water acts as a base when it gains an hydrogen to form the hydronium ion. A. Water loses proton to form hydroxide, acts as an acid or redox reactant. Water accepts a proton from H3PO4 to become H3O, acts as a base, and the C. This is an oxide hydration reaction, not a simple Bronsted-Lowry acid base pair transfer for water. D. Water molecules inside the complex lose a proton to NH3, acts as an acid. So the correct answer is B. Question 36. Sulfur dioxide is used as a preservative in winemaking. The following equation describes how sulfur dioxide dissolves. Which statement about these two reactions is correct? As you can see, here's the equilibrium reaction. According to the Bronsted-Lowry theory, a base is a proton acceptor, and the sulfide ion accepts the proton to become the hydrogen sulfide. Looking at the options through the lens of proton transfer, HSO3 acts as a base because in the first equation, HSO3 plus H was water plus sulfur dioxide. It's as a proton to reform dissolved sulfur dioxide and water. Number 37. According to the Bronsted-Lowry theory, the product consists of ammonium ions and bicarbonate ions. Ammonia has accepted a proton to become NH4 with a plus charge, meaning it is acting explicitly as a Bronsted-Lowry base. The correct answer is B. Wait. Well, I think number 35 is same like number 38. It was same B. Because, yeah, it was a same. Wait. Yeah, it was a same question, so you can hear my explanation in number 35. Yes, you can listen to my explanation there. We move to the number 39. In which reaction is the underlying substance X acting as a base? According to the Bronsted-Lowry, a base is proton acceptor. In reaction C, the hydrogen carbonate ion accepts proton from nitrous acid to temporarily form carbonic acid, which immediately breaks down into water and carbon dioxide. So the correct answer is C. And then Before we enter the paper 2, we get to answer the question 4. With the correct answer is C, 2 and 3, because of the statement 1 is incorrect because of acid 2 has a lower pH because it is strong acid that dissociates completely, not because of its solubility. Uh, because of its solubility. Statement 2 is correct. Base 2 is a strong base that fully dissociates, giving it a higher concentration of hydroxides ions than the weak base. Uh, Statement 3 is correct. Acid 1 has a higher pH than acid 2 at the same concentration because it is a weak acid and dissociates less. Finally, we move to the paper 2. Okay. Well, we start by paper 2 at A1 and A2. As you can see there, the question. The relative charge of each plate for the left plate is positive and the right plate is negative proton. The reason is protons carry a positive charge and are repelled by a like charge, so they bend towards the negatively charged plate on the right. Conversely, electrons carry a negative charge and attractively curve toward the positively charged plate on the left. Then to the A2, behavior of a separate beam of neutrons. Answer is draw a straight vertical line starting from the source that goes directly upward without bending toward either plate. The question is, on the diagram, draw a line to show how a separate beam of neutrons from the same source behave in the same electric field. As you can see, there's the picture of the neutron. It was like a straight line, vertical. In there. Then we move to the paper 2, question 1b, B1. The correct answer is the orbital is 4, 9, and 5. The explanation is, as we know, krypton electron configuration is as shown in the picture. First, the s subshells contain one orbital, 1s, 2s, 3s, 4s equals to 4 orbitals. P subshells contain 3 orbitals, p, x, py, pz. Then it was 3 subshells times with 3 equals to 9 orbitals. D subshells contain 5 orbitals. 1 subshells times with 5 equals to 5 orbitals. We move to the B3. Question 1b3. Correct answer is 5. With the explanation, first we identify the orbital type. The dumbbell shape shown in the diagram represents a p orbital. Find the electron configuration of fluorine. Has 9 electrons distributed as picture shown. Count the electrons looking at the p subshell 2p5. There are exactly 5 electrons occupying the p orbitals. Paper 2, question 2A2. Describe how an atom chromium 54 differs from an atom of chromium 52. Refer to numbers of particles in your answer. Chromium 54 has 2 more neutrons than chromium 52, or 30 neutrons instead of 28. They have the same number of protons and electrons, 24. Isotopes are atoms of the same element with the same number of protons and electrons, but a different number of neutrons. The question explicitly asks you to refer to numbers of particles in your answer, which is why stating it has a different mass didn't get the mark. This is the total number of unpaired electrons in an atom of chromium. Total number of unpaired electrons is 6. To find the unpaired electrons, look at the outer subshells that are not completely full, 3d and 4s. The 3d subshell contains 5 individual orbitals filling 100 rule. The 5 electrons fill them singly 5 unpaired electrons. The 5s subshells, 1 orbital with 1 electron, which mean had 1 unpaired electron, so total of unpaired electrons is 6. Next, we move to the question number 3. Most elements exist naturally as a mixture of isotopes. each with their own relative isotopic mass. The mass spectrum of an element reveals the abundance of these isotopes, which can be used to calculate the relative atomic mass of the element. Magnesium has 3 stable isotopes. Information about 2 of these isotopes is given, as you can see. Then we must calculate the percentage abundance. Well, first the percentage of abundance. It was 100% minus 79% minus 11% equals to 10%. And then calculate the relative isotopic mass. So the percentage abundance is 10%, and for the relative isotopic mass, we use the formula 24.3 equals to 24 times with 79 plus 26 times with 11 plus x times with 10 divided by 100. Then we just calculate it, and then in the end we get the x equals to 24.8. So the percentage of the abundance is 10% and the isotopic mass is 24.8. We move to the question 4a2. Shape of a 1s orbital. Well, the answer is just draw a simple uniform sphere with a neat 2D circle satisfy exam requirements. Do not draw dots on the ring or a central nucleus labor orbit diagram, and an s orbital is purely a spherical boundary cloud. So all you need is just draw a simple circle with a 2 orbital, like you can see in this picture, in the equation picture. There is the number of unpaired electrons in a cobalt atom. Number of unpaired electrons in a cobalt atom, 3. Explanation is D subshell has 5 individual orbitals. Placing 7 electrons in the 5 orbitals using Hahn rule means the first 5 electrons enter singly and the remaining 2 pair up. This leaves exactly 3 orbitals with single unpaired electrons. Okay, so for the rhodium, as you can see, we must give some details to this table. First, the number of protons for rhodium is 45, number of neutrons is 58, and the total number of electron shells, it should be 5 because of number of protons given by atomic number is 45, and the number of neutrons calculated by subtracting the atomic number from the mass number is 58, and the total number of electron shells rhodium is located in period 5. So the answer is 5. We move to the question 4c. The table shows abundance of isotope in a sample of an alloy containing rhodium and iridium only. We use the relative mass formula, isotopic mass times with the relative abundance divided by 100. So multiply mass by abundance for each isotopes. Then we got all of it, all the values, and then sum the values together. We got 14,763.14, and then divided by 100, it was equal to 147.63. Final answer is 147.63. If it was given to the 2 decimal place, you can use that, but if it's rounded to 3 significant figures depending on your exam's instructions. Next to the question 5a1. Define relative atomic mass. Relative atomic mass is a average mass of an atom of an element compared to 1/12 of the mass of a carbon 12 atom. A2. Calculate relative isotopic mass of the third isotope of iron in the sample show you're working. Okay, show my work hand here. there's the table, and then the third isotope abundance, we can use the percentage abundance from the table. 100% minus 6 minus 91.9 equals to 2.1% isotopic mass calculation. Then we just calculate them all until we got all you need is just to input the number into the isotopic mass formula and then calculate it, and then you get X is equals to 56.9. Now we move to the B. That is the number of pairs electron in the 3D subshell in a iron 2 ion. The answer is 1. The explanation is neutral iron atom Fe has the outer configuration 3d6 and 4s2, leaving just 3d6. To form an iron with 2 plus charge, it loses its 2 outermost electrons from the 4s subshell, leaving just 3d6. 3D subshell has 5 individual orbitals. When you arrange 6 electrons, use Hans rule. The first 5 electrons go into the 5 orbital singly, and the 6 electron must pair up in the first orbital. So there's only 1 pair of electrons and 4 unpaired electrons. Okay, to the Q5C. Sketch the shape of the lowest energy orbital in the shell with principal quantum number. Well, all you need is just drawing a center of atom like this, and then make a circle. So that's all how you gonna make it. There's nothing to not really hard to draw it. It's just a circle with the center of with atom circle, also with the inner circle. So it is the shape of the lowest energy orbital. N equals to 2. Next to the question 6a. Well, this is the last question, but has a part of it. Define enthalpy change of formation. The enthalpy change when 1 mole of a compound is formed from its element in their standard states under standard conditions. We move to the B1. Iron is made when iron oxide is heated with carbon monoxide as shown by reaction 2. Okay, show the enthalpy change of formation data measured at 298 Kelvin and 101 kilo pressure. By adding equation with relevant state symbols to represent standard enthalpy change of formation for this chemical equation and standard enthalpy change for formation for carbon oxide. As you can see, this is the value of enthalpy change. So all you need is just draw the core equation like this. To represent the enthalpy change of formation, you must form basically 1 mole of the compound from its constituent elements in their standard states. Here are the correct equation with state symbol to write table 4.1. Why you write an answer was incorrect. This is a fatal one. You started with Fe2O, iron 2 oxide, a compound instead of the pure element iron. So for the carbon oxide, C plus half of oxygen and gas solution, and then you get carbon oxide. To the question 6 B2. Here are we use the Hess-Logan products minus reactants. Sum of the products is 3 times with a minus 393.5 equals to minus 1180.5. Then the sum of the reactants, you can calculate it, and then it got minus 1155.7. With the calculation of the Hess law, we got a minus 24.8 kilojoule per mole. Okay, question 6C1. In the bonds overlaps, put exactly one dot and one cross in each shear space to show a single covalent bond. On chlorine, each has 6 crosses left over group as 3 pairs. On sulfur, it has 4 dots left over group as 2 pairs, one at the top or one at the bottom. So this is the true the correct answer for it. As you can see, here's the chlorine, sulfur, and the chlorine. Okay, question 6c2. Uh, Predict the shape of an bond angle in a molecule of sulfur chloride by using VSEPR theory. Shape is bend or V shape, and bond angle is 103 to 105 acceptable, like 104.5. Explanation. First, you count the electron pairs. The central sulfur has atom 4 electron pairs around it, 2 bonding pairs attached to the chlorine atoms, and 2 lone pairs. Determine geometry. 4 total pairs give a tetrahedral arrangement, but because 2 of them are invisible lone pairs, the actual molecular shape is bent. Determine angle. Lone pairs repel more strongly than bonding pairs. They squeeze the bond angle down from the perfect tetrahedral angle of 190.5 to approximately 104.5. Okay, we move to the last question. Is question 6D. Okay, as the shown table, calculate the enthalpy change of direction of chloride in gas and with ammonia in gas. Balance equation first, then we got this equation, and then sum of products 6 times with minus 92, sum of reactants 2 times with the minus 46. Then we got this in calculation we use the Hess law again, the enthalpy change, so we get the minus 460, and that's the enthalpy change of this reaction. Well, I think that's all from me. That's the last question. Thank you for paying attention. And thank you so much for my teacher, Ustazah Helena Rohilahi. I hope uh, I can learn chemistry better uh, at next semester and get a better score at the next examination. Thank you so much for your time. So thank you, and that's all. Wassalamualaikum warahmatullahi wabarakatuh. Goodbye.